So if A and B are two sets, -1, 4, 5, and B is 2, 3, what if A cross B, we have to find their Cartesian product. So first we will write the first element -1, 4 and 5, okay, and then we will write 2 and 3. So -1 is mapped to 2, then 4 is mapped to 2 and 3. So this is 3. I have written first, okay, so then 2, 3. So that way we can write A cross B, we can define it. Okay. Now let's define a set -1, 2, 4, 2. Okay, this is a set that I have defined. Now what is the relation between C and A cross B? As you can see here, -1, 2 and 4, 2, they are, C is made up from the elements of A cross B. Similarly, D, if you see, D is -1, 3, 5, 2, 5, 3. So here also -1, 3, 5, 2, 5, 3. So B is also, D is also made up from this. Okay, so what are C and D? The question is this. So as you can see clearly, you can say that C is a subset of A cross B, and so is D. So C and D are a subset. Let's define are a subset of A cross B. Let's define a set E, which is exactly the same as A cross B. So in that case as well, we can say that E is a subset of A cross B. However, it is equal to A cross B as well. Okay, what if I ask you phi? So phi is also subset of A cross B. So whichever set, if we define, which seems to be a subset of A cross B, that defines what we call, what we are going to do next is relations. A relation is basically a set, okay, defined from set A to set B. These are two non-empty set. Then a relation R defined from A to B. Here this R seems to be a bit in a cursive writing kind of thing. Okay, why this is written in this specific cursive way? Because this we need to differentiate from capital R, which represents set of real numbers. That's why it is written like this, guys. Okay, but still we call it R. Okay, so defined from A to B. Okay, such that R is what? R is a subset of A cross B. So R is a subset of A cross B, then R is a relation defined from A to B, okay, and it is a subset of A cross B. So if I ask you, is E a relation? If E is, let's say, is E a relation from A to B? If we define a relation from A to B, so yes, E is a relation from A to B. Before that, relation R, specific relations can be defined. They are denoted by letters like R1, R2, R3, and so on. So now E, instead of E, if I ask you, if this is, let's say, R3. So R3 is a subset of B. I will rub this E as, replace this E by R3. So R3 is a subset of A cross B. So R3, we call it, R3 is a relation defined from A to B. Relation defined from A to B. In the similar way, if I ask you, let's say this is, these are two relations. This is R1, this is R2. Okay, so R1 and R2, guys, are also subset of A cross B. So R1 and R2 are also said to be relations defined from A to B. So this is the example of a relation defined between, defined from set A to set B. Okay, which is a subset of A cross B. Now see here also A cross B is written. Now R1, is defined as -1, 2, 2, 3, 5, 2 is R1 is relation from A to B. So we need to check that all the elements from R1 should be what, guys? Yes, they should belong to set A cross B. So -1, 2 is this, it is there. 2, 3, 2, 3 doesn't seem to be here. 5, 2, 5, 2 is here. So 5, 2 is and -1, 2, they both are present, but 2, 3, it's not there in A cross B. So R1, if the question is A to B is a relation, answer would be no. R1 is not a relation from A to B. Let's take another example. Again, it is the same type. If A is PQRT, B is 07865, and R1 is defined as 0P7Q7T, is R1 a relation from A to B? So let's check 0 comma P. We need to check, there is no need to find A cross B fully, just we need to ensure that the first element 0, 7, 7, they should be a subset of A set A. Okay, so 0, 7, 7, relation from B to A. Right, here you should understand that so far we have seen examples from A to B. B to A means the first element should belong to set B, that is A. Second element should belong to set B, set A. Okay, first element should belong to B, second element from A. So 0, 7, 7. So 0, 7 is there. So yes, it is correct. Now the second element should belong to which set? It should belong to the second element is P, Q and T. So P, Q and T, they are belonging to set A. So yes, we can say that R1 will be a subset of B cross A, guys. It would be, if you calculate B cross A, however it's not required, it would be a subset of B cross A, because the first element 0, 7 is a part of B, and the second element PQT is a subset of set A. So we can also say that a relation is a subset of A cross B. So the first element set is a subset of A, and the second element set is a subset of B. That way also we need to understand. Okay, so the answer is this relation. So yes, clearly we can say it is a relation. Yes, it is a relation. Now let's take another example. This PQRT is A, B is 07865, P8, 7QR6, 5T is a relation from A to B. So again we need to check the same. Okay, so just try this. So the first element P R. Now as you can see here, P R, the first element 7, 5, they are belonging to both the sets. However, the first element should belong to the set A only, because it is defined from A to B. Now P, Q is P and R are okay, but 7 and 5, they are belonging to set B, so they shouldn't be a part of the first element. So is this a relation from A to B? So clearly it's not, so answer would be no. Now let's take another example. Define a relation R1 from A PQRT to B 865 containing PR and 86 only. So defined from A to B. Okay, so clearly PR we will take, and it should contain 86. So we can write the first elements in P and R like this. So P we will write, R we will write. Now second element should belong to 8 and 6, should be 8 or 6. So we'll fill it with 8, 6, 8, 6. So that way it is done, guys. Now, guys, let's see what do we mean by representation of a relation. So, while defining it, we defined the relation, we wrote it like in the form of ordered pair. So, the first obvious way of representing it, and it is quite frequently used as well, it is ordered pair representation. So, example like A and B, if it is given to be PQRT B07865, so these are the subsets of A and A cross B, P8, 7Q, R6, Q7, R7. They all, you can see, they are subset of A cross B. Why, guys? Because the first element, you see, P uh, R, okay, and QR, this seems to be a bit wrong, guys. 7Q, it should be Q7. Okay, so these are Q, R, P, they are part of set A, and 8, 7, 6 are part of set B. In R2 also, Q and R are part of set A, 7 is part of set B. Okay, guys, so this is what we have seen so far, an ordered pair representation, but we used it for defining the relation also. Okay, the second is arrow diagram representation, guys. So arrow diagram representation, instead of writing ordered pair, we will write A and B in oval circles, okay, in elliptical circles, and inside that we will write the elements. So this is the same example I have taken, PQRT and 0786. Like if I want to define R2 here, so R2, as you can see here, it is this Q7, R7. So now what I will do, Q7, I will make an arrow. So that's why it is called arrow diagram represent R7. So this I call, this is a relation R2 defined from A to B, and then elements which are associated from A to B are connected by an arrow starting from an element of set A and ending at set B, okay, ending by an arrow mark, okay. That's why it's an arrow diagram representation, guys. Like AB is given to be, if it is like this, A and A is PQRT, B is 07865. So if R2 is P8, Q5, T5, T0, draw the arrow diagram, guys. So as usual, A and B we will write as PQRT and 07865. Okay. Now from A to B, we will define what is given to be R2. So now P is connected by 8. So P I will connect by with an arrow. So this is first. Now this is done. Now Q5. So Q5, Q would be connected to 5. Now after that T5. So T5 is connected like this. Now T0. So T5, after T5 it is T0. So T is connected with 0 like this. So this is the arrow diagram representation of R2, okay, like this. Now if suppose R1 is given to be like this, we have to convert and write in ordered pair form, guys, okay. So A to B, we need to write, guys, R1 A, R1 B, okay. So we have to write in ordered pair. Now the meaning of this -1 arrow 0 means in ordered pair representation it should be -1 0 ordered pair. Now similarly -1 6 means -1 6 in ordered pair we have to write, followed by the next is, which is 4 comma 6. So 4 comma 6 we will write like this, guys, 4 comma 6, followed by the next, which is 5 comma 8. and 5 comma 9, two ordered pair starting from 5. So 5 comma 8, 5 comma 9 we will write, comma 5 comma 9. So this is the R1, which is representation in ordered pair of this arrow diagonal representation conversion. Okay. Now second form is what we call set builder form, guys. Set builder form is the same as what we have done in set. What it was, set builder form is an indirect way of indicating the possible values, possible elements of any set. So in the similar way, if a set, if a relation R, it is not defined by writing the elements in ordered form or arrow diagram. It is a indirect way where any element A comma B, where A is an element of A and B is element of B. A and B basically are related mathematically. That formula, that relation would be given inside this pair of braces, or a rule. A and B are related by a rule. That rule is also either specified, would be specified verbally in that. So let's take an example. See, here we need to define relation, define in ordered pair representation. Okay, write R1 in ordered pair representation where R1 is defined as A comma B. A comma B will always be written such that A and B are natural numbers satisfying A plus B equals to 5. So guys, A comma B, so A and B will write, that is the hint, and then A comma B we will write the ordered pair. So we need to, since A plus B is 5, we need to do trial and error, hit and trial. So we'll start with A as 1, 2, 3 and so on. So A, if I take 1, okay, so if I take 1 plus B is equal to 5, the value of B would be 4. Similarly 2 plus 3, so B is 3. 3 plus 2, it is 5. Now 4 if you take, it will be 1. Okay, so natural number it is 5. So the ordered pair corresponding to this is 1, 4, 2, 3, 3, 2, 4, 1. That's it. After that it won't be possible. So these are the 4 ordered pair which I have written it here. Okay, that is the answer. Now if suppose in the next example A is 27, B is 0, 1, 5, R2 we need to define AB. A is in A, B is in B, and A, B minus A is an even number. Okay, is an even number. So write R2 in what? In as ordered pair, guys. Okay. So the solution would be A and B are given. So we will put the values of A and B and find B minus A. So we can take A as 2 and then see which B should fits into this to make B minus A as even number. So if I take A as 2, which value from 0, 1, 5 we need to take so that B minus A is even? So clearly it is 0. So ordered pair, so B minus A, 0 minus 2 is minus 2, which is even. So the answer is 2 comma 0. Similarly, what else? Nothing else satisfies, so we will take A as a 7. Now which value of B we should take? So clearly B1 fits into this. 1 minus 7 is minus 6. So 7 comma 1. Now 7, what else? 7 and 5 also can be taken, so that 5 minus 7 minus 2 is again even. So 7 comma 5 is another ordered pair. So how many ordered pair we got, guys? 2, 0, 7, 1, 7, 5, 3 ordered pair we got, guys, which can be written as like this: 2, 0, 7, 1, 7 comma 5, which is the answer. in ordered pair representation R2. Okay. Now similarly, this also you try, write R3 in ordered pair where R3 is p comma minus p square and p is greater than equal to 1 less than 5, p is a natural number. So how you will define R3? So as you can see here, this should be this should be understood that this is minus p square. So this is minus of p square it is. Okay. So p is 1 to 5 means p would be what, guys? P is a natural number and 1 to 5 here equality is not there. So p can be 1, 2, 3 till 4 only. 5 it cannot be because there is no equality here. So the possible values of p is 1, 2, 3, 4 only, which I have written here. So if you square it, 1 square is 1, so minus 1 it becomes 2 square is 4, which is minus 4, 3 square is 9, which is minus 9, minus 16. So the ordered pairs are these are the 4 ordered pair possible, okay, which is the R3. Okay. Now let's define another term related to this, which is domain of a relation defined from A to B. So domain is basically what, guys? Domain is basically set of all those values of A which are a part of the relation R. Means domain of R is a subset of A, set of all values of A, or we can also define it as set of first values of A comma B, where A comma B is a relation. Means here if I ask you what is the domain, if this is, let's say, R3, which is defined as like this, so domain of R3 is the first value set. So first value set is what? 1, 2, 3, 4. So 1, 2, 3, 4 is the domain, guys. That's it. Okay. So since A was not specified, as you can see here, the set A was the set was not specified here. We will see more examples on this. Okay. So domain is always a subset of set A if the relation is defined from A to B. Okay. So this is a set of first values of A and B. That is, we can also say that if in a more clear and mathematical way, if we define it, domain of R is A, where AB belongs to, AB is an element of relation. Like if relation is given to be 1, 2, 1, 3, minus 1, 5, what is domain R? So clearly we can say that it is 1 minus 1. Here if I say that A is 1 minus 1, 2, for example 7. So as you can see, this domain is a subset of A. That is what I wanted to, explain. Domain of R is a subset of A in case of a relation. So this is domain of R. Okay. So previous examples also, if you see here, if you see here also, like this in this example, this is the domain of, if I ask you the domain, so domain is what? Domain of R1. So it would be minus 1. Minus 1, we won't write it double, only once we will write minus 1, 4, 5, 4, 5. That is the domain, guys. Okay, as you can see here, minus 1, 4, 5, 6. It is a subset of minus 1, 4, 5, 6. So this is the first element collection, which is the domain of a set of a relation R. Now, similar to that, we can define another term, which is the range of a relation R, guys. The range of a relation R is defined from A to B, is again, it is set of all values of B. Previously it was A, which are a part of relation R. So obviously the range of R would be a subset of B, because sometimes it can be, in most of the cases it would be lesser than B, or set of second values of B. Second value means B, collection of B, where B is an element of set B. So for example, if we take R1 as 1, 1, 2, 1, 3, minus 1, 5, what is range of R? So clearly we can say the second element collection, which is 2, 3, 5. So 2, 3, 5 is the range of R1, guys. Okay. So in previous examples also we can see, like here, if I ask you what is the range of R, so range of R would be what, guys? Range of R1. So second element collection 0, 6, 6, 8, 9. So 0, 6, 8, 9. Okay, guys. Here as you can see 0, 6, 1, 8, 9. So it is clearly it's a subset of B. 0, 6, 8, 9, 1. So range is subset of set B. So that is the range. Okay. Here also, if I ask you what is the range of R2, so range of R2 would be 8, 5, 0. So range of R2 would be 8, 5 and 0. So this is range, guys. Now let's define another term, which is what we call the inverse relation. The inverse relation R inverse, R minus 1. This shouldn't be confused with 1 by this. This is not this. This is simply R inverse, we call it. So R inverse is simply writing it in reverse order. See, if an element B, A comma B is there in R in a relation, just interchange them, you will get B comma A. So the set of that, we define it as R inverse, guys. For example, if I ask you, in this case, what is R inverse? So as you can see here, 1 comma 2, we will reverse it, we will interchange the value, so it becomes 2 comma 1. Similarly 3 comma 1, it becomes 1 comma 3 becomes 3 comma 1. Similarly minus 1 comma 5 will become 5 comma minus 1. That is R inverse, R1 inverse, guys. That is the inverse. Okay. So we can define any inverse relation, we can define like here, if this is R2, if I ask you what is R2 inverse, then what you will write? So 2 comma 0 would be written as 0, 2. 7 comma 1 is 1, 7. 7 comma 5 would be written as 5 comma 7. Okay, guys. So this is the inverse relation, R inverse. Okay. So what is the relation between domain and range of R and R inverse? Now if I ask you what is the domain of R and range of R inverse in terms of domain and range of R. So as you can see here what was a part of the domain, the range of R1 2, 3, 5, now it became a part of domain of R1 inverse. So they are interchanged. Domain and range, domain of R inverse we can say is what, guys? It is range of R. And in the similar way, range of R inverse can be written as domain of R, guys. Okay. So guys, let's take an example. If A is a set containing these 4 elements, 2, 3, minus 1, 4. So minus 1 we call as what? we say that -1 is an element of set A. Most of the times we have seen in a set that the elements are single values, like some letters or some numbers. Now take this example. In this, A is like this. A is 1 comma 5 comma -2 comma 4 0 comma 2. So instead of some numbers or some letters, what we have is something like this: 1 comma 5, which is separated by comma inside two pair of round brackets. This is what we call, guys, ordered pair. Ordered pair, we have seen that it is used in answering the inequality, or it is used to used as a symbol in denoting a coordinate. Okay, and in sometimes ordered pair is also denoted as some values of x and y. Let's say if x is 1, y is 1, so one of the ordered pair of the values of x and y is 1 comma 5. So this is what an ordered pair is: two numbers separated by comma inside two round brackets. So 1 comma 5, now here I want to emphasize is this is an element instead of a single number or a digit. So an ordered pair, even a triplet, can also be an element of a set. That we will see later. As of now, this is how we define an ordered pair to be. Okay. So ordered pair in general is A comma B. Okay, where A and B are generally some numbers. So why an ordered pair came here? Let's see. So guys, ordered pair is basically defined for what purpose? So here we want to define the product of sets A and B, which we denote simply by A multiplied by cross B. Okay, so how do we define the Cartesian product of these two sets A and B? A and 2 are two sets. So A and B, let's say A is an element of A, B is an element of B. The Cartesian product of two sets A cross B, first of all, this is also a set. Okay, and it is, the elements are, instead of some numbers, as I said, it can be some ordered pair. So here also it is the same. A comma B is an ordered pair. So there are so many ordered pair depending on number of values of A, small a in set A and small b in set B. So A cross B is A comma B. So how do we define a cross of two set, guys? So A and B is an ordered pair, as I said. Okay, so let's take an example. If A is containing only one element -1 and B is containing 0 to -1, what is A cross B? So first of all, what we will write an ordered pair. First number A cross B, A, it will be of A. Second number in the ordered pair belongs to B. So first number, as I said, as you can see, it is -1 and there is a comma. So the question arises, what is the number after the comma? So as I said, you might have guessed as well that it is numbers from set B. So as you can see here, 0 to -1, they will be substituted here. So 0 to -1. So these are the three elements of A cross B. So this is A cross B, guys. Okay, this is the answer. If suppose in the same question, if I ask you, what is B cross A, guys? Okay, so A is as usual -1, B 0 to -1. So B cross A, now the first number will belong to which set? Yes, the first number in the ordered pair will belong to B, for comma followed by number belonging to set A. So as you try, it will be looking something like this. The first number belonging to set B is 0 to -1 followed by comma, and then what we will write, guys? Yes, the number from set A, which is -1 only. So -1 -1 we will substitute here. Okay, so now let's take another example. If A is -1 4 and B 0 to -1, what is A cross B? in a similar way. And the second question is B cross A and A cross B same? Okay, so we will A cross B, so we will take first element belonging to set A, and then comma set B elements we will write. So now A has two elements, so first we will write -1 element of set A, and then there would be three triplets corresponding to three elements of B, which are 0, 2 and -1. Now after this, what will come next? So yes, it will be uh, three more triplets containing number 4 belonging to set A, then 0, then again 4, then what will come? 2, then again 4, -1. So these are the 6 elements of A cross B. Now B cross A, the second question is B cross A cross B are same? So as you can see here, if you try to calculate B cross A, you will see something like this. So if we calculate B cross A, first we will write the elements of set B, which are 0, and 2 times we will write, because number of elements in A are 2 only, so -1 -1. Now we will write the two numbers of set A, which are -1 and 4. So we will put -1 4 like this, -1 4. Now as you can see here, if you check these two, A cross B and B cross A, can you say that they are equal? Like there is an element 0 comma 4 here, but there isn't any element 0 comma 4 here. However, there is element 4 comma 0, so they are not same. Okay, there may be some common elements, but as of now in this question they are not same, and usually they are not same. Okay, so A cross B, generally in almost all the cases they are not equal. Okay, so A cross B and B cross A, in general they are not equal, except some cases, okay, that we will see later. So as of now they are not equal. So now if A is B is the same question, if it is what we have done. Now the question is, what is number of elements in A cross B? So as you can see here, if you see A cross B, we have written 3 elements here, okay, of B corresponding to, there were 2 elements. So we can say there are 6 elements, but they were obtained something like 2 elements of A, 3 elements of B. So it is 6, guys. Okay, so 6 elements, as you can see, A cross B has. Okay, so can we generalize it, A cross B or B cross A? So yes, if you take any, if you can generalize it, if number of elements in A and B are given, then we can find number of elements in A cross B and B cross A, which would be same as the product of elements in A and B, guys. Okay. Now if B cross A is given to be 0 3 0 4 1 4 2 4 2 3 1 3, we have to find A and B. So how we can determine this, guys? What should be the hint? So we can proceed like this, like if A comma B, from the definition, if it is given, then the first element will belong to set A and second element belong to set B in case of A cross B. Okay, so in case of B cross A, it would be, should be what, guys? It should be the reverse. The first element, okay, it should be belonging to set B in case of B cross A, and the second element should belong to set A, guys. Okay, so that we will take as a hint. So the solution would be, now as you can see here, B cross A, it is given to us. Now we will take first element, which is 0, it is written twice, 1, it is also written twice, 2 here and here. It is also written to us. So 0, 1 and 2 are elements of B. Okay, so we can directly say that B is 0, 1 and 2. Okay, now we will see the second element. 3 is coming here, here, here. It is coming thrice. Similarly, 4 is coming thrice. So it means the number of the elements of set A, they are nothing but what? They are nothing but 3 and 4. 3 and 3 comma 4. They are the elements. Okay, so that way we can solve this, guys. So this is B cross A, and so A is, our answer is 3 comma 4, B is 0, 1, 2. That way it is done. Now what if one of the sets, guys, is phi? If A is phi or B is phi, or both are phi and an or, then what about A cross B? What do you say, guys? So guys, if any one set or both doesn't have any element A cross B, we cannot make. Okay, because we need ordered pair, and if here there is nothing in the first element or the second element is nothing, ordered pair cannot be formed. So A cross B will also be will be defined as nothing but as phi. So A cross B, in that case, if either or both are phi, then A cross B is phi, guys. Okay. So in a set builder form, if a relation is expressed, relation is between set A to set B. So AB, the ordered pair, then two dots. Okay, A belongs to A, comma B belongs to B, and condition between A and B. This condition can be a mathematical equation, inequality, a mathematical, or something which is a mathematical relation which is verbally described. So this is what I mean by condition between A and B. Now this whole thing can be written like this also, guys. A R B. Okay, the first element A, then R, that is the relation. B, if and only if, okay, double arrow we can also say, if and only if condition between A and B satisfies. Okay, relation between or mathematical equality between A, B, inequality between A and B is satisfied. So it is written like this. So this is rather another way of expressing a relation which is we don't have to write much in this. Okay, so that way we can write. Let's take an example on this. If a relation is defined like this, guys, relation A comma B such that A and B are natural numbers and their sum is 4, so it can also be written as AB belongs to N and B belongs to N can also be written as A comma B belongs to N into N square. So this is another way of expressing, where A and B belongs, and if they are belonging to the same set, instead of writing this, we write this. Okay, so both ways, and then we will write only A plus B equals to 4. Now the another way of writing this relation is, as I said, ARB we will write both sides double arrow if and only if A plus B is equal to 4, A comma N, B comma N. Instead of this, I can also write what I have written, what we have seen this here. I can also write it as A comma B belongs to N square. Okay, that way also it can be described. So now the question, we need to solve this. Okay, and we can solve it by assigning one value of A and then getting B. These kind of questions we will see, or we may have seen. Okay, So let's move on to another question, uh, which is this. A is a set containing elements 2, 3, 4, 5, and B is set containing 7, 6. A relation R1 is defined like this. A R1B if and only if HCF between A and B is what? 1, where A belongs to set A and B belongs to set B. That is the question, guys. So a relation R1 is defined. The question is, write R1 in ordered pair form. So how we can do this? So what's the hint? What's the concept involved in this? Okay, the hint part that we will see now. Okay. So obviously, we will take one number each from A, set A and set B, and check their HCF if it is coming out to be 1. Okay. So we will take one number each from A and B and check for their HCF to be 1. That's our approach, and that way we will do. So the solution part goes like this. So A is 2, 3, 4, 5. So first we will fix A as 2. Okay. And then we will think as to what should be the value here so that it is 1. From B, 7 and 6 are given. So if you think what should be placed here, so yes, it should be 7, so that the HCF for 2 and 7 is 1. HCF means highest common factor. Highest common factor, we know that HCF of, for example, 4 and 3, there is no common factor, so it is 1, like that. Okay. We can say they are co-prime with respect to each other. Okay. So HCF, now what about 3? 2 is done. What about 3? 3 we have placed here. So what value should be placed here out of 7 and 6? If you place 6, HCF won't be equal to 1, it would be 2. So definitely we need to place 7 here as well. So this is 2, 7, 3, 7 is another 2 ordered pairs we got. Moving on with 4. Okay. Now what we need to substitute here, 7 or 6. If you substitute 6 here, the HCF would be 2. Okay, it would be 2. It won't be 1. So definitely 6 won't come. So we will put 7 here as well. So it is 1. Now it's a turn for 5. 5 we will put here. If you put 7, you will get HCF 1. Even if you put 6 also, you will get HCF 1. The common factors are 1 only. So as you can see here, there are how many ordered pairs satisfying? 1, 2, 3, 4, 5, which is this, which is the answer in ordered pair. Okay, guys. So if suppose we have to find number of relations R which is defined from set A to set B, A R, A to B R, where if it is given that NA number of elements in set A is P and set B is Q. So what are the number of relations that can be defined from set A to set B? So guys, we know that any relation, first of all, we know that NA cross B is NA into A, NB, which is P into Q. And we also know that any relation is a subset of A cross B. In other words, any subset is any relation. Any possible subset of A cross B is basically any relation possible from A cross B. So it means what? That number of subset, if we can calculate, of A cross B, which is 2 to the power PQ, because number of subset of a set A having n elements is 2 to the power n. So A cross B having PQ element is 2 to the power PQ. So number of subset of A cross B it has to be equal to
number of relations are, okay, from A to B. So that is the answer. Number of relations is 2 to the power, if it is defined from A to B, Na into Nb, guys. That is the number of relations R that can be defined between two sets A and B, A to B. Okay. Now, for example, find number of relations that can be defined from A to B if A is this and B is 0, 2, 4, 6. So clearly it depends on number of elements of A. So A is minus 3, 4, 5. So Na clearly is 3 and Nb has 4 elements. So 3 into 4, 2 to the power 12 is number of subsets, guys.